Okay, welcome back. We're talking about the replacement for the whole BIOS system. So the UEFI could be a couple of megabytes. I mean, it's pretty good size compared to the old system. And so that's one of the advantages. But the other one, it could be pretty doggone smart. So there's an awful lot of acronyms here, but there's a GUID partition table, which you have to understand what GUID is. GUID is globally unique identifier. So a GUID partition table basically is just a way of picking up partitions. See, in the old system, you could have no more than 4 partitions in a system. Now, one of those partitions, or a few of those partitions, could be what's called extended partition. So you could have a partition inside a partition. But for real, because it had to fit in, very, very tiny, 512 byte little structure there was only 4 slots. And so when we needed more than that, we cheated and it had like sub slots. But with a good partition table, screw it, you can have as many as you want. It doesn't matter. You want 150 partitions on your system, fine, go right ahead. Okay. So there's an EFI partition table, and every machine has one. And oddly enough, it's a. No, here's the weird part. Okay. Now, you know how if you've ever messed with Windows systems before, you know what a Windows file system is, right? There's FAT and FAT32 and NTFS, those kind of things. Nod your head if you halfway remember. Okay. So in this case, this partition table, this partition thing, is a physical spot on your drive. I mean, it's honest to God, a real honest to God partition on your machine, formatted in FAT. Now, typically it's not mounted, and if it is mounted, it's not mounted read-write. Okay, but you can mount it read-write. Let me just show you a cool thing. Let me get back to our good old Linux guy here. Oh, I'm in the middle of lessing, aren't I? Okay, cool. So I'm going to do something called EFI. Dang it. EFI boot MGR, and then just have it show me everything there is. Oh yeah? Okay, fine, I'll do that. I don't know why I thought that was already installed. Okay, sudo apt get install EFI boot MGR. Alright, CIS4335 2020, boink. Okay, and then I'll try that again. Aha! Okay, well apparently in the virtual world there's not enough tie to the EFI. Okay. Normally in a real world system this would have spit out a whole bunch of information about how our boot partition was set up. Okay. So going through the next thing on the list, remember that little chart, I'm not going to show it to you again. So the bootloader. Now, the bootloader, technically, if you're using an EFI or a UEFI system, you don't really need a bootloader if it's only one system, right? You really only need a bootloader if you're loading multiple operating systems on the same physical machine. Okay, so in our case, we don't necessarily see the bootloader because what the bootloader normally would do, it'd prompt you and say, which operating system would you like to boot now? Well, if you only have one, there's no point in asking the question. So it just goes right on through that guy and we never see him. So it does have a boot time interface, a little menu that you can use, your arrow key and hit enter. You can have it so that it counts down. If you don't answer within 5 seconds, it'll automatically go to whichever one you tell it to be the default. That's kind of cool. It also provides you an opportunity to say, wait a minute, I want to boot this operating system, but I want to boot it in a different mode. Unix from day one and all the derivatives have a way of booting the system up into the multi-user mode, the more common thing that we see. And then it also has a way you can boot in what's called the single user mode. And that means I can log in and I can do stuff, but nobody else can. So it's just me and the administrator hooked up on the machine and I boot it up in the special mode. No one else can get on. For example, if I'm repairing something or getting ready to restore a file from a backup or something, I might want to boot to single user mode, that's how you do it. You do it through the bootloader. Okay, on page 35, they talk about Grub, the grand unified bootloader. And once again, people got together and said, look, this is crazy. We need a bootloader that's going to work for Linux and for, Mac OS and Windows and all sorts of things. Whatever the heck you have on your machine. So we need one bootloader that's going to work for everybody. So they came up with Grub. Okay. So, having said that, can I use Grub on my Windows system? Let's forget about Linux. Let's say I have a Windows 7 system and I'm getting ready to install Windows 10, but I want to keep my Windows 7. Can I install Grub so that every time I turn my machine on, it says, hey, which would you like, Windows 7 or Windows 10? Yes, you can. It works pretty doggone cool. Okay. By the way, if you did it the old way, using the Microsoft technique, the only way that would work is if you installed the operating system in chronological order. In other words, you couldn't install Windows 10 and then later install Windows 7 on another partition. It would mess things up. You'd have to go back in and tweak things. With Grub, it's like, we don't care. Kind of cool. So Grub is that universal thing. Kind of like it. So there's some text files. So if your system supports Grub and you're using Grub, I'm going to go to etc. default, if I spell it right. Okay, cool. And then there's a grubd guy. So that file, I'm going to go ahead and I'm going to run VI on it. I don't have write permission, but that's okay. So I'm going to say VI grub. So this is a configuration file that basically goes in and say, here's what we need to do. Okay, so we put the grub default and the timeout at 0. If we change the timeout to 5, then it would come up and say, hey, would you wait 5 seconds for me to pick one. And then the default is what's called this ubiquity, which is the kind of the cool name for the version, the flavor of Linux that we installed. Go figure. Anyway, this is some of the stuff, and you can change the background image or the color. I mean, you can do all sorts of weird stuff that, quite frankly, no one really cares about. Okay, so if you had this enabled and you type the letter C stands for choice, that'll stop the clock, because of like a 5-second timed out, and then you can use the up arrow key and find something you want. Okay. So there's a whole list of Grub commands on page 38, but, just take a peek at them, okay? So typically, one of the things that you could use Grub for is, remember when we fire up our machine and like once a month we'd go and do an update, and about once a week we do an upgrade? Remember all that? Well, if during this period of time you actually got a completely new Linux kernel, okay? Those things come out occasionally. We're not talking about tiny little things that are happening. We're talking about, honest to God, real huge changes to the kernel. If that happens, it's going to build it's going to build Grub. It's going to build a second slot for you that when you boot up, you can say, do I want the current version or the previous version? Ooh, cool. So it does this automatically. You don't have to tell it to do that. So one of the things you can do is you can have one version of using Grub. You can have one version which is just a normal, honest to God Linux. Then you can have another one which is a special mode called kernel debugging. Okay, kernel debugging means there's more stuff packed into the kernel for doing diagnostics. Now, the normal average human would never ever do kernel debugging. But let's say I'm writing a file system, or I'm writing a device driver for Linux. Then you might want to switch over to this other mode. Now, you don't normally leave it on that mode because it's kind of slow and pokey, and there's lots and lots of instrumentation, so to speak. Places where things can stop and report back what they're doing. We don't need that in a production world. So one of the things you can use with Grub is to have a kernel debug mode and a normal mode. Kind of cool. Okay. So the next one, on page 41, they start talking about the system management daemons. So what the hell is a daemon? And maybe hell is the right question. So no, it has nothing to do with hell. It's not a demon, it's a daemon. Okay, So remember how when we did, I'm going to go back to the home directory. So remember we did the PS command? And I'm going to do PS AUX, and I'm going to pipe it through less. I don't remember how many there are. And so, see where it says init? Init is process ID number 1. Okay? Process ID number 1 is init. So what happens is, init is the starting point, okay, of the way the kernel boots up. And I mentioned there's other modes. There's a single user mode, which just boots the system up and lights up one user. That way you can't have multiple people on at the same time, which is kind of cool. Multi-user, which is everybody, that's the normal. That's called init 2. Init 1 is, just me. Init 2 is everybody. And then there's a serverless one, or headless. Maybe that's a better choice. A headless version where you're running, the init is running, but it's not providing you any command interface whatsoever. There's no login, okay? So login only for me, login for everybody, and login for nobody, okay? Those are the common things, modes that init has. So there's basically a task list here of the things that it does. So this is what happens, okay? Believe it or not, your machine doesn't know its own name until init runs. And so when init runs, it goes and finds where you told it what the file name is. Oh, it knows the file name. Wait, it's going to check the file system. We haven't talked about the file system check FSCK guy, but that's the guy that goes out and does, checking of the disks to make sure that nothing is broke. And then it mounts the file system, and then it removes the old files from temp. Remember how I told you how temp is set up to not retain, okay? And it configures the networks, and it turns on the firewall and the packet filtering and startups. So it starts up with, with complete amnesia. The machine's, here's your name, here's your time zone, here's where you are, kind of a cool list. Okay, now there have been some really, really strange things that have happened in the Linux world. So the init system was the original one from AT&T, and it was pretty good. And then a lot of people switched over to something called Upstart, and Ubuntu did. Ubuntu switched over to Upstart, which is basically just a better version of init. Okay. And then several years ago, they switched over to another one called System D. And boy, if you want to see some crazy stuff, you should just Google init versus System D. There is wild stuff in here. I mean, there is wars fought over, oh my God, you're switching over to System D. Oh no, I don't want that. Anyway, bottom line is there's 3 different techniques for starting up a system. The old system called init, the newer one called Upstart, and then init System D. And System D is the one that we're currently using in Ubuntu. So let's just talk about it. So init is kind of dumb, okay? Init basically says, look, I'm just going to do these things, but you need to tell me what order to do them in, Oh, for example, I don't want to start web services before the network is started, right? That makes plenty of sense. So you need to tell me what order these things have to go in. And there's no dependency checking. Like, for example, if I'm starting up, I'm trying to add a new one to init, man, I got to figure out where it goes in the list. Because if I put it too high, and like web services, if I put web services too high in the init file, the init.rc file, then I've screwed up. I need to move it, So it was kind of it was good, but kind of clumsy. It had tremendous support for lots of people because you'd write these little shell scripts that start things, and you could have logic in there. Say, well, if that didn't start, try it one more time. That kind of thing. All right. So it was broken down into individual pieces, and each piece had to do its own thing. When System D came out, they said, we'll handle it all. One giant monolithic thing that will do it all. And a lot of people just had a philosophical problem with that. Okay, but we'll discuss that again right after the break.